Dear students, I would like to speak with you about Euclidean theorem. In the right angle triangle, the area of the square on a side of the right angle is equal to the area of the rectangle whose dimensions are the length of the projection of this side on the hypotenuse and the length of the hypotenuse. In the opposite figure, if triangle EBC is right angled at E, D belongs to line segment BC, where line segment ED perpendicular to line segment BC, then AP square equal BD times BC, AC square equal CD times CB. Notice that BD is the length of the projection of line segment EB on straight line BC. CD is the length of the projection of line segment EC on straight line BC. Corollary: if triangle EBC is right angled at E, D belongs to line segment BC such that line segment ED perpendicular to line segment BC, then AD square equal BD times DC. We can deduce the previous corollary as follows. Since triangle EBD is right angled at D, therefore EB square equal ED square plus BD square, Pythagoras theorem. Therefore ED square equal AB square minus BD square. But EB square equal BD times BC, Euclidean theorem. Therefore ED square equal BD times BC minus BD square equal BD open bracket BC minus BD close bracket equal BD times DC. Remark: if triangle EBC is right angled at E and D belong to line segment BC such that line segment ED perpendicular to line segment BC, then ED equal EB times EC over BC, and we can prove that as follows. The area of triangle EBC equal half BC times ED equal half EB times EC. Therefore, ED equal EB times EC over BC. We can deduce the Euclidean theorem and its corollaries using similarity of two triangles as follows. In the opposite figure, EBC is a right-angled triangle at E. D belongs to line segment BC, where line segment ED perpendicular to line segment BC. In two triangle EBC and DBE, since measure of angle BEC equal measure of angle ADB equal 90 degree, angle B is common. Therefore, measure of angle C equal measure of angle BAD. Therefore, triangle EBC similar to triangle DBE. By the same way, in two triangle EBC and DAC, since measure of angle BAC equal measure of angle ADC equal 90 degree, angle C is common. Therefore, measure of angle B equal measure of angle DEC. Therefore, triangle EBC is similar to triangle DAC. From 1 and 2, therefore, triangle EBC similar to triangle DBE similar to triangle DEC. Since triangle EBC similar to triangle DBE, therefore EB over DB equal BC over BE. Therefore EB square equal DB times BC. Since triangle EBC similar to triangle DEC, therefore EC over DC equal BC over EC. Therefore EC square equal DC times BC. Since triangle DBE similar to triangle DEC, therefore DB over DE equal DE over DC, therefore D square equal DB times DC. Since triangle ABC similar to triangle DBE, therefore BC over BE equal EC over DE, therefore DE equal BE times EC over BC. In the following, we write the summary of the relations of Pythagoras theorem and Euclidean theorem. BC square equal EB square plus EC square. EB square equal BC square minus EC square. EC square equal BC square minus EB square. B square equal BD times BC in the second figure, but in the third figure, C square equal CD times CB. In the first figure, D square equal DB times DC. In the last figure, EG equal EB times EC over BC. In the opposite figure, XYZ is a right-angled triangle at X. Line segment XL perpendicular to line segment YZ, such that L belongs to line segment YZ. YL equal 9 cm and LZ equal 16 cm. Find the length of line segment XY, the length of line segment XZ, the length of line segment XL. Prove, since triangle XYZ is right angled at X, line segment XL perpendicular to line segment YZ, therefore XY square equal YL times YZ. Euclidean theorem. XY square equal 9 times 25 equal 225. Therefore, XY equal 15 cm. Similarly, XZ square equal ZL times ZY. Euclidean theorem. XZ square equal 16 times 25 equal 400. Therefore, XZ equal 20 cm. Since XL square equal LY times LZ, corollary, therefore XL square equal 9 times 16 equal 144. Therefore, XL equal 12 cm. Another solution to find the length of line segment XL. XL equal XY times XZ over YZ equal 15 times 20 over 25 equal 12 cm. And we can find the length of line segment XL using any of the two right-angled triangle XLZ or XLY using Pythagoras theorem as follows. In the right-angled triangle XLY, XL square equal XY square minus YL square equal 15 square minus 9 square equal 225 minus 81 equal 144. Therefore, XL equal 12 cm. In the opposite figure, triangle ABC is right angled at B and D belong to line segment EC, such that line segment BD perpendicular to line segment EC. EB equal 8 cm and CB equal 6 cm. Find EC and DB. the length of the projection of line segment BC on the straight line EC. The length of the projection of line segment EB on a straight line EC. Dear students, best wishes from me for all of you, and thank you very much. Goodbye.